Adding and subtracting. Okay, now once again, keeping the steps straight in your head is what's important. Just like with all the other ones, you know, like we can't confuse them. So we're going to be solving rational equations. So an expression is just a statement. So right here is an example of an expression. We've been simplifying, adding and subtracting, multiplying and dividing expressions. Now when we start getting into equations, there's an equal sign, and we're going all the way to solve for x. We would never solve for anything if it was just an expression. There's not an equal sign, so there'd be no way to solve. But because we have an equal sign, we will solve with the following steps. First, determine the domain so that we know what solutions we cannot have. So we have to, this is going to be nice because remember last year how we didn't really do this first, and what would happen is we would solve it and then we would check our answers for extraneous solutions, and a lot of times they were extraneous because they were what made the denominator 0. So I decided let's just restrict first, that way we know when we get to the end, if we get 3, throw that solution out. We don't even have to check it, you know? So, yeah, that's a good way to do it. So first we'll determine the domain, meaning what our restrictions, so we know what solutions we cannot have. Second, factor the denominator only, similar to adding and subtracting, and get least common denominators. You really only want to factor the denominator. Then once you have a least common denominator, it's nice because you can just ignore the denominator and solve using the numerator. You can just ignore the bottom and solve using the top. So you just have to remember you can't do that when adding and subtracting, because once people learn this, they'll start doing that for adding and subtracting. And then fourth, we still will just check our solutions, basically just to make sure we've done things right. We should really take care of any extraneous we come upon by restricting first. Okay, so right here's an equation. Let's just solve it going through the steps here. So first we would restrict. We'd say when we solve, in the end, x cannot be 3 or x cannot be 2, correct? Then we would go on. It says factor the denominator only, which it's factored, and then get a least common denominator. So it looks like with two terms, remember I always use parentheses, so I'm going to go fix that. So we're going to multiply by x minus 3. No, we're not. X minus 2 and x minus 2. Then this one's going to multiply by x minus 3 and x minus 3. Now we've done, it says step 2, factor denominator and get a least common denominator. Done. Third step is we can literally just now ignore the denominator completely and solve using the numerator. So look, I'm just going to literally ignore it. Now let's write out the numerator. So it is kind of the same steps because remember our next step in adding and subtracting would be to multiply out the numerator only. That's kind of what we're doing now. So we got a double distribute here. X times 2x would be 2x squared. Then we have x times negative 1, so that'd be negative x. Then that looks like that's going to be minus 4x. And then we're going to have a plus 2, which is equal to, look, equal sign, and then we're going to multiply 3 things out. When multiplying 3 things out, shouldn't you multiply 2 together and then multiply it into the third, everybody? So I'm going to just take 2 in right here, right now. So then I'm doing 2x plus 2 times x minus 3. So then we have 2x squared. Looks like we're going to have minus 6x. We're going to have plus 2x. And then we're going to have minus 6. So now that's our true statement. This equals this. So combine like terms. We're going to combine like terms and solve for x. So on this side of the equation, we have 2x squared. We have minus 5x's plus 2 is equal to, on this side of the equation, we have 2x squared minus 4x's minus 6. So solve for x. So shouldn't we get it equal to 0? That's one way of doing it, right? It's quadratic. Or combine like terms. So if you notice, when we go to say, okay, let's bring our x squareds together, subtract 2x squared, subtract 2x squared, then doesn't it go away completely? So then you're not dealing with a quadratic, so we're not going to get it set equal to 0. We're going to combine our x's and solve a linear equation. So negative 5x plus 2 equals negative 4x minus 6. So let's solve for x. So bring your x's together, add 5x, add 6. So then on this side I have 8 is equal to 1x. So x equals 8. There's our solution. Was that a restricted value? No, it was x cannot be 2 or 3. So that's correct. It's not going to be extraneous. And you can check to see if you did it right by plugging it back into the original, which I'm not going to take the time to do right now. Are you mad if I don't? Okay, awesome. Pretty easy stuff, as long as you don't make errors. Okay, let's do another one. Right, because we're just solving. So good question. So because we're solving to make it a true statement, you see how the denominators are the same? So if we plug in 8, it will be the same. So it won't matter essentially, but in adding and subtracting, obviously it matters. We got to keep it, but with this one we're solving. Okay. So with this one it says factor. We have to do our first step, restrict. So let's restrict. Now it's easiest to restrict if your denominators are factored, but look. This piece doesn't factor. What multiplies to be 4 and adds up to be 0? It would need to be 2 times negative 2, which is not positive 4. So this is one that doesn't factor. Now remember, if I tried to set that equal to 0, look, x squared plus 4 equals 0, because it can't equal 0. Subtract 4, x squared cannot equal negative 4, so square root, x cannot equal plus or minus 2i. We're not going to have i's as restrictions, remember that? So you'd say there's no restriction there. And then on the other part, what will x not be able to be equal if we solve? So set it equal to 0, subtract 2, divide by 3. So x cannot be negative 2/3, right everybody? Okay, so let's factor the denominators, done, because that didn't factor, get a common denominator. So we're going to multiply this by 3x plus 2, 3x plus 2. We're going to multiply this by x squared plus 4, true? And x squared plus 4? Are your denominators the same? Yes, everybody? They each have the same element, so now we can ignore it. So now we're multiplying out the numerator, so that's 3x squared minus 12x's plus 2x's and then minus 8 is equal to 3x squared plus 12. I distributed. Then you combine like terms. So 3x squared minus 10x's minus 8 is equal to 3x squared plus 12. So you'd say, okay, it's a quadratic. Normally when solving a quadratic, we get it equal to 0. But in this case, once again, our quadratic goes away. Because when we combine our x squareds, they go away. So then we're just dealing with negative 10x minus 8 is equal to 12. How do we solve linear equations? Get x alone. So we'd add 8 over. So negative 10x is equal to, if I add 8 over, 20. So then x is equal to negative 2. Now you would say, okay, cool, it's equal to negative 2. That's not the restriction. It's not a restricted value, so we're most likely good as long as we've done the math right. And we could check it by plugging it in. So you could go like this. Negative 2 minus 4 over negative 2 squared plus 4 should equal, 3 over 3 times negative 2 plus 2. So up on top here I'd get negative 6. And then on bottom I would have negative 2 squared is 4. So 4 plus 4 is 8. That's equal to 3 over, right here, 3 times negative 2. Negative 6 plus 2 is negative 4. And that does simplify to be the same thing, because if we simplify 6/8, they both divide by 2, don't they? So this would become a 3, this would become a 4. So look, it did come out right. Great question. I like that you asked that. So remember, negatives can be on top or bottom, right? You can switch them back and forth and it won't matter. Good question. But they can't be on both, right? Okay. Awesome. Good questions. Okay, let's look at this one and see if we're... Okay, so first step is you say there's an equal sign. I need a common denominator. What would the least common denominator be? Look at your numbers, 6, 2, and 3. Can't we make them all 6? Yes. Then they need an x. So you'd say, I need to make all the denominators be 6x. So I multiply by 6 over 6. This one needs an x over x. True? This one needs a 3 over 3. And then this one needs a 2x and 2x. And then you say, okay, make sure my denominators are all the same. 6x, 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 6x. So now I can ignore it. Multiply all the numerators. So we have 12 minus x is equal to 15 minus 2x. Do you guys see where I got it? Then you'd say it's a linear equation. We solve linear equations by combining x's. And so we have 12 plus x equals 15, so then subtract 12. So x is equal to 3. Uh-oh, I forgot to restrict first. That's okay. I can always go back and say in the denominator, the only restriction was x could not be 0. True? So x equals 3 is all good. So guys, you see how it is a lot more straightforward than last time. There's not a lot of work involved necessarily compared. So looking at this one, our first step is to factor out the denominators. So you'd rewrite it. You'd say, okay, right here's a quadratic. I got to hurry and factor that. What multiplies to be 3 and adds up to be negative 4. 1 times 3, negative, negative. I can quick factor. So you'd rewrite the denominators factored. P minus 1, P minus 3. Moving on to the next one. You'd say what multiplies to be negative 3 and adds up to be negative 2. 1 times 3, negative 3. I can quick factor. So I have a plus sign, then I have a 6, and then that's over P plus 1, P minus 3. Then we have an equal sign. We have a 5. And then this is a quadratic. It multiplies to be negative 1 and adds up to be 0. 1 times negative 1. I can quick factor. So I have P plus 1, P minus 1. Okay, so we need to get the denominators to look the exact same. This one has a P minus 1. Does this one have a P minus 1? No, so it needs a P minus 1. Does this one have a P minus 1? Okay, moving on. P minus 3. Does this one have a P minus 3? This one does not, however, so we need a P minus 3 here. Then looking at this, P plus 1, P plus 1, this one's missing a P plus 1. So we multiply by P plus 1. P plus 1. And now look at your denominators. As long as they're the same when solving, we can ignore the... Oh, wait, let's restrict first. P cannot equal negative 1, 1, and 3. And now we can ignore our denominators and just solve with the numerator. So you multiply that out. So we have 3p plus 3. I'm distributing. Plus sign. We have a, if this was a minus sign, wouldn't we need to distribute the negative, everyone? Okay, just making sure. So then we have plus 6p minus 6 should be equal to 5p minus 15. And then solve. So combine like terms. So that's 9p minus 3 equals negative 5p. No, that's not a negative 5. Positive 5p, my bad. Minus 15. So then combining our p's. Yep, 4p. So you'd subtract 5p over. Subtract 5p, subtract 5p. So then you have 4p. And then we'd add 3, wouldn't we? Negative 12, so therefore p equals negative 3. Was that a restriction? No, so we've done it right. And we don't have to throw it out.
So, wait, so we've done it right and then
No, that's not true. It's just, that's not true. I shouldn't have said that, because that's not true. We could have done it right and got p equals 3, and then we would have said no solution, because that can't be a solution, and that was the only solution we got. So I should not have said that. I'm glad you corrected that. So guys, how can I know on the test if I've done it right? Plug in negative 3 into the original, you know, but you got to be able to calculate it, right? Using parentheses. Okay, cool. Okay, there's going to be times when we get a quadratic. So when we get a quadratic, we have to solve. So let's just do one like that. Let's see, I'm trying to remember. This is one that has a quadratic involved. Meaning just when we solve, it ends up being a quadratic, which we know how to solve quadratics. We get them set equal to 0, we factor, we solve. So we'd say, okay, we need a least common denominator. So we have a w minus 1. This one doesn't have a w minus 1. It needs 1. This one has a w minus 1. We're good. This one needs a w. Two terms, put parentheses. This one needs a w. So then you'd say, okay, my restrictions are w cannot equal 0 or 1. If we get one of those solutions, they're extraneous. Ignoring denominator, multiplying out numerator. So we would have w squared plus 3w plus sign. And it looks like we have a double distribution, w squared minus w plus 5w minus 5 is equal to then it looks like distributing that through 3w squared plus w. So combine like terms on this side to make it prettier. So w squared and w squared would be 2w squareds. And then we have so 2 w's, but then plus 5 w's, so plus 7 w's minus 5 is equal to 3w squared plus w. Now look, you have a quadratic equation. The w's would not go away because they're not the same on both sides. So we're going to have to remember, we solve quadratics by first getting it equal to 0. So I'm going to subtract, I'm going to actually bring these over because I don't want to have a negative in front of w squared because then I can't quick factor. So I'm going to say, okay, so I'm going to subtract 2w squared. So I'm going to bring this over to subtract 7w. So I'm going to bring this over to plus 5. Because now we have a 0 is equal to 1w squared. And then it looks like we have minus 6w's on this side plus 5. You'd say, I solve quadratics by factoring it and getting it equal to 0. So you'd say what multiplies to be 5 and adds up to be negative 6. Multiplies to be 5 and adds up to be negative 6. So it's either 1 times 5. Well, it's got to be 1 and 5, doesn't it? And then negative, negative. Then you'd say I can quick factor. So w minus 1, w minus 5. So w equals 1, w equals 5. Okay, let's go back up. Let's remember those solutions. So w equals 1, w equals 5. Which one would be extraneous? The 1, because it can't equal 1. So we would just throw that answer out. It's not that we've done it wrong, it's just that it's extraneous. See how much better it is to like restrict first? Why didn't I think of that last year? Because remember, we'd check it and then get it's extraneous. This is way easier. Yeah, exactly. When we would probably, on a test, plug in 5 into the very original just to make sure we didn't mess up somewhere. And then it would work. Okay. Awesome. I think we get the picture here. Do you agree? Okay, I won't do another one then. Okay, let's just read this so that people are not confused on how to tackle the problem. It says, for the function f of x is equal to x plus 4 over x. It was kind of squished, so this is what it is. So it says, for the function f of x is equal to x plus 4 over x, solve f of x equals 5. So now people get confused because remember there's a difference between f of x equals 5 and f of 5. Where should I be plugging 5 in? Yeah, in front of the equal sign, look, it replaces f of x. It says f of x is equal to 5, not f of 5. f of 5 just means plug in 5, which if we were told to do that, then great. But this is saying f of x equals 5, so that's a 5. So you'd say 5 is equal to x plus 4 over x. So guys, this is just an equation we just learned to solve, just barely. We get a common denominator, don't we? Now look, don't let these denominators that are missing throw you off, because look what you should be doing. They do have denominators. They're 1. Do you guys see? Any denominator that's not there, write a 1 under it, and then go from there. So you'd say common denominator needs to be x. So times by x over x, x over x. So then you have 5x, because, oh, and we'd say x cannot be 0. So that would be our restriction. Now we can ignore the denominator. 5x equals x squared plus 4. How do we solve quadratics? Yep, get it equal to 0 by subtracting 5x. So then you're saying that it's x squared minus 5x plus 4 equals 0. So then we factor it. We'll multiply to be 4. Adds up to be negative 5, 1 and 4, negative, negative. So then we get x minus 1, x minus 4. So our two solutions are x equals 1 and x equals 4, right? Now it says, what are the points on the graph? Now guys, when we solve quadratics, aren't we finding x-intercepts? So our y value will always be 0. So you'd say, okay, so x was 1 and our y is 0. X is 4, our y is 0. So those are the xy points. Our restriction was x can't be 0, and it's not. It's 1 and 4, so we're good. Just making sure that we understand. It's just testing the same knowledge we just learned, but in making you set it up. Okay, awesome. That is the end. Okay, wait. Let's just look at this one real quick. Okay, so how would we do this when it says Because we have to be able to do some story problems. So here's a story problem, okay? Because we can't say that we can't do story problems, because a lot of you are seeing, if you don't do the story problems on the test, your score comes down to an 80% just from not doing the story problems. Then if you miss anything else, now you're in the 70s. So watching. It says, a concentration C of a drug in patient's bloodstream in milligrams per liter T hours after ingestion is modeled by this. So guys, a lot of times they're going to have this big wordy thing, but it's just like, this is the equation. What does each thing stand for in the equation? It says, when will the concentration of the drug be 4 milligrams per liter? So where should I put the 4? Yeah, in front of the equal sign. So you'd say, when does 4 equal 40t over t squared plus 9? Now how do we solve? Get a common denominator. So this is over 1. So then you'd multiply by, yep, t squared plus 9. You need parentheses since it has two terms. T squared plus 9. Then can't ignore the denominator. So then you would distribute. You'd have 4t squared plus 36 equals 40t. How do we solve quadratics? Get it set equal to 0. So we have 4t squared minus 40t plus 36 equals 0. It's still going to be quick factoring, because can't I pull out a 4? So this is really not that hard of a problem. Just because there's words in it doesn't make it hard. So we pull out a 4, then left is t squared minus 10t, then it's plus 36 divided by 4, isn't that, yeah, 9, we just did that, 9. Okay, what multiplies to be 9 and adds up to be negative 10, 1 and 9, negative, negative. So we have a 4, we have a t minus 1, we have a t minus 9. Now will this affect my solution? Not when solving, right? When factoring we'd need it, but we're just solving so we can ignore it. So t equals 1, t equals 9. Now time is in minutes, oh, hours. 1 hour or 9 hours? You see how I get two answers? 1 hour or 9 hours? Because, good question. So you're saying, why isn't there one extreme? Like, why isn't there one? That actually can happen with story problems. So it's like, I don't really know how bloodstream things work, but I'm wondering if, like, at a certain point, so it says concentration of a drug in a patient. I don't know. I wonder if what happens is, like, after 1 hour, after 1 hour, it's like at a point, and then it dies, and then it dies down, like I don't really know how it works, but then like 9 hours later, your body has digested it, and there's some spike or something. I don't know how it works. So it'd say 1 hours or 9 hours is when we're seeing it.
So if you get two solutions and ask for one,
It didn't necessarily say just what's one though, right? It just is saying when will this happen. So here's the thing, was either of those restrictions? No, right? If I set that equal to 0, subtract 9, square root it, it'd be 3i. So neither of those were restrictions, so they both work. Now if one of them would have been negative, yeah, we throw that one out. So it just depends on the problem. Okay, I think that is the end. Okay, so, ready to go. Practice a few.